Hey everybody, and welcome to this quiz for your Network Plus exam, where I'm going to give you one question from every single exam objective to give you a rough idea of how ready you are for your exam. Stick with me if that sounds good. We're going to go ahead and get straight into it with the first question, which reads: a large enterprise network is experiencing intermittent connectivity issues impacting several departments. A network technician is dispatched to troubleshoot the problem. Upon investigation, they discover a critical component, a device with multiple ports, each connected via Ethernet cables to various workstations and servers. This device's sole function appears to be receiving electrical signals from one connected device and regenerating those signals to all other connected devices, essentially extending the reach of the network segment. It operates without examining MAC addresses or IP addresses, simply boosting and repeating the signal physically. Which layer of the OSI model does this device primarily operate at? Is it A, layer 1, B, layer 2, C, layer 3, or D, layer 4? Your answer is coming in 3 seconds. Pause the video if you do need more time. 3, 2, 1. That's absolutely right. The answer is A, layer 1. So, this question does rely on you understanding what the OSI model is and what the different layers are. Layer 1 of the OSI model is essentially the hardware component. It's the cables, it's the raw data. There is no attempt to correct any errors. There is no attempt to filter based on MAC addresses or IP addresses. It is the cables, the connectors, the data rates, the physical structures without any MAC addresses or IP addresses or anything any more high-tech than that. That description is essentially all you really need to know to understand what layer 1 is. But of course, we do need to know about all the other layers. So the OSI model, hopefully if you're taking this quiz, you are somewhat familiar with it. This isn't an entire course, but I will give you a quick rundown of roughly how you can understand this for your exam if you're doing a last-minute study session. So the OSI model is essentially a way of understanding how the different things within a network can be categorized. The different layers perform different tasks, and each layer has different hardware that is associated with that layer. So layer 1 we just talked about, that is the physical layer. That's dealing with the physical transmission and reception of those raw bit streams over a physical medium. In English, that means it's your hardware, right? Your cables, fiber optic, Ethernet, whatever type of cable may be, a hub, which is what was being described in that question, by the way, which is just where a signal goes in, and that's sent to every other device plugged in. There's no attempt to send it to a specific device. A repeater, right? The raw hardware. And data at this level is called bits. You'll also need to know what the data is called at that level, because they may ask you that on your exam. I will give you some simple hints and tricks to help you remember all of this on the next little bit, but data at that level is called bits. Layer 2 is the data link layer. Long story short, you can read that, but if they mention filtering data based off of MAC addresses, that's going to be a giveaway that you are looking at the data link layer. And then we need to know what kind of hardware does filter based on MAC addresses. So of course, a switch generally filters based on a MAC address. The Ethernet cable is plugged into the switch. The switch then understands the MAC address of each individual hardware component, and it sends the data to whatever device it needs to go to based on the MAC address. And data at this level, or layer, is called frames. So that's important to know. Data is called frames at that level. Layer 3 is the network. The giveaway for layer 3 or network is if you see anything to do with IP addressing, right? So if the data is being filtered based on IP addresses, or if we're looking at a piece of hardware that generally operates utilizing IP addresses. So one that you should be thinking about there is routers, for example. Routers use IP addresses to filter. Layer 4 is the transport layer. So this is what is essentially responsible for ensuring the reliable transfer of data, the data delivery and data flow between applications. So the giveaway for this is we're looking at TCP or UDP, right? If there's any mention of transmission control protocol or user datagram protocol, we're looking at layer 4, because these are essentially the protocols that are used to transport data. We know that we have a wide variety of ports that we can operate on, but on these ports, you're either going to be using TCP or UDP to do that, right? And that is the transport. These are the protocols we use to transport data. So that is the transport layer. Layer 5 is the session layer, and that is essentially the layer that is responsible for managing, establishing, and terminating communication between applications, okay? So you essentially need to know that if the question mentions anything about establishing connections, managing connections, or terminating connections, we're looking at the session layer, okay? And from this point forward, data is simply called data, all right? It is just data for everyone moving forward. Layer 6 is the presentation layer, and that refers to translating data into a format that the application layer, which is the next one, can understand. Basically, that just means we're taking that data and we're doing something with it to actually make it something that is visible or usable, whether that be compressing it or encrypting it or formatting it. So some examples here, you can see JPEG, MPEG, SSL or TLS encryption, right? If you are compressing it, formatting it, or encrypting it, that is the presentation layer. And then that gives us to layer 7, or brings us to layer 7, which is the application layer. And that is the final product that the end user is actually interacting with. That gives us that full functionality. That's a lot to take in, guys, which is why this video isn't really a one-stop shop for this. But if you just need a quick refresher, here we go. So a quick tip that you can use to remember this, 2 mnemonics. The layers, what I used when I was studying for this was, please do not throw sausage pizza away. Please, physical, do, data link, not network, throw, transport, sausage, session, pizza, presentation, away, application. Please do not throw sausage pizza away. If you can remember that, you'll be sweet. And then the mnemonic that I use for remembering the names for different types of data is banks fight people, so don't do deals. Banks, bits, fight, frames, people, packets, so segments, etc. Right? Banks fight people, so don't do deals. So if you can remember these 2, that's a nice little hint that I used when I was struggling to remember that for my exam, which helped me out a lot on exam day. Now, that came from exam objective 1.1, which is basically just explaining concepts related to the OSI model. So this is all they say in the exam objectives, but everything I laid out there is pretty much what you're going to need to know for your exam. So make sure you do know that before you go ahead and take your exam. The next question reads from exam objective 2. A remote scientific research team is deploying a long-term, non-temporary communication system in a challenging mountainous environment where traditional cellular or wired internet is unavailable. Each researcher's device, such as laptops, specialized sensors, and handheld communication units, is configured to directly connect to any other device within range. If a device needs to send data to another device that is out of its immediate range, it automatically relays the data through intermediate devices until it reaches its destination. There is no central router or access point. All devices cooperatively maintain connectivity, and that the failure of 1 or 2 devices does not cripple the entire network's ability to communicate, though it might lengthen the path. Which type of network is the research team deploying? A mesh network. B, ad hoc network. C, point-to-point network. Or D, an infrastructure network. Your answer is coming in 3 seconds. Pause the video if you need more time. 3, 2, 1. Absolutely correct. Your answer is A, a mesh network. If you got that one wrong, don't worry about it. We're going to go over what all those were really quickly right now. So a mesh network is essentially when you have a wide variety of devices all connected to one another, so that let's say I'm over here and I wanted to send data to this device over here. I may not have a direct connection, but I can go through this device and then through this device and then come over here, right? And the key thing that characterizes a mesh network is the fact that it is a decentralized structure. So there is no particular router that is at the center of all of this. The devices communicate directly with one another and relay that data, all right? Redundant paths are a key thing as well, which basically means, let's say I might go from this device to this device. I usually take this path from here to here to here. If this one goes offline, I have redundant paths, meaning, oh, this one's offline. Instead, I can go from here to here to here to here. Okay, so there's always going to be some sort of fail-safe path you can take. That's pretty much it, really. Largely speaking, that's what you need to know. The other options there, one of them was an ad hoc network. Now, this is like a really simple version of a network. Basically, it is where you're doing a temporary, decentralized connection. And that might sound similar. Here's the key differences. One, it's very temporary, unlike a mesh network. It is decentralized, which is similar, but really an ad hoc network, you're looking at direct peer-to-peer communication, which essentially means, like, you might be connecting one phone to another phone for a very temporary connection so that you could transfer some files while you and your friend are on the train, or you might be tethering from your phone to your laptop, for example. That's what we're looking at in relation to an ad hoc network. So it is not this complicated mesh network with a wide variety of different redundant fail-safe pathways that is designed for long-term, medium to long-term use. No, it is a very simple peer-to-peer connection. Tethering for a super short amount of time is essentially how you want to think about it. And so long as you get that, you'll understand it. This just talks about those differences that I just discussed there. Pause and read if you want to, but I think we get the picture now. The other option was point-to-point network. This one is just a dedicated connection between 2 points. Generally, you're going to have a very fast connection here because it is a dedicated connection between point 1 and point 2. The data knows exactly where it is going, and there's nothing really changing about that. So it is going to have the entire bandwidth dedicated to those two endpoints, meaning that it's going to be very, very high speed and have low latency. It's easier to be secure here because it is a direct link. You don't have to manage a wide variety of different connections. It is simple and it's reliable. So point to point is from one point to another point, nothing in between, no different pathways. It's just a highway, right? It's a highway going from A to B, no shortcuts, no scenic routes. The other option was an infrastructure network, and this is the more general network structure we think about, right? Where you do have centralization. You've got that router in the middle. That's the default gateway. All the data goes through that default gateway if it wants to leave the LAN. It's the general sort of network that you're looking at really most of the time in any sort of office building or anything to that effect. It uses your standard devices such as routers, switches, access points. It is scalable, but you can easily add new devices in. It is your general network that you think about, right? So if it's a network using a router and switches and patch panels, then it's going to be an infrastructure network. All right. So hopefully all that made sense. That came from exam objective 2.3, and I've highlighted the specific section there, network types. Essentially for your exam, you're going to need to be able to have a look at an example or description of a network type, and then be able to accurately say what network type is being described, or alternatively, make a recommendation as to what network type someone should use based on their requirements. The next question from exam objective 3, we're almost there, guys, reads, a financial services firm processes millions of transactions daily. Due to strict regulatory compliance and potential financial losses, they have a critical requirement. In the event of a system failure, the maximum acceptable amount of data loss that can be tolerated is 15 minutes. This means that after a disaster, the restored systems must not have lost more than 15 minutes worth of transaction data. Which disaster recovery metric does this requirement directly address? A, RPO, B, RTO, C, MTTR, or D, MTBF? Your answer coming in 3 seconds. Pause the video if you do need to do that. Here we go. 3, 2, 1. The answer is A, RPO, or recovery point objective. So look, there's a bunch of different terms you need to know in relation to recovery and in this particular exam objective, and I'll show you exactly where it's from in a second. But basically, you need to know these different letters and what they mean. So you need to be able to look at a description and say, okay, that's what this is. Now, what is RPO? It is recovery point objective, and it's essentially what defines the maximum acceptable amount of data loss. But it's not measured in data, it's actually measured in time. So in this case, it was 15 minutes worth of data loss. It's a bit confusing, but so long as you can wrap your head around that general concept, that's really all you need to know. So it is the maximum tolerable data loss in time format. So it is, of course, important for compliance, because if you work in financial services, if you have a low RPO, generally that's going to be really important to maintain that low RPO, meaning that if your system goes down and you're losing a certain amount of data, you want to keep the amount of data that you're losing as low as possible. All right, because if you don't do that, customers won't trust you. But just know RPO stands for recovery point objective, and it's talking about how much data you can afford to lose in time-based format. The other options there are on the exam. They're not made up. You do need to know them. Is recovery time objective, or RTO, right? What we just talked about was RPO. That's about how much data loss is acceptable. This one, RTO, specifies the maximum acceptable duration of time for which a business process or system can be unavailable. So if your data center goes down, what is the maximum amount of time that you can actually afford to have that down before you have it up and running again? So it's the maximum amount of downtime. So this is really talking about how fast can you recover, all right? Largely, that's what you need to know. RTO is recovery time objective. How much time can you afford to be down before you need to be back up again? Another option there was mean time to recovery, and RPO and RTO, which is what we just looked at, are focusing on data loss and system unavailability. But mean time to recovery is measuring the average time it takes to fully restore that system or restore that component to normal operational status after a failure occurs. So the last one, which was RTO, is having a look at this one that we just talked about, is saying, okay, how long can we afford to be down before we have an unacceptable amount of damage to the business, for example. But MTTR, or mean time to recovery, is specifically looking at the time between the failure and the coming back online. So they seem quite similar, but there is that slight difference, and I'll go over that again. But mean time to repair is basically talking about the restoration process. How long does it take you from shutting down to being back up again? And talking about RTO, right? This MTTR goes beyond just bringing a system back online, which is what RTO is about. It also includes all steps to ensure full functionality, stability, and data integrity post-incident. So we're really looking at how long between shutting down and getting back up again before everything is exactly as it needs to be. All right, so the lower your MTTR, the more efficient your incident response and your recovery procedures are going to be, essentially. All right. So businesses are always working to make this number as small as they possibly can. So just one more time. RTO is how long can this be down before we suffer more than we can stand to suffer. MTTR is what is the period of time between downtime and being completely back up and functional again. All right. That's a bit of a tricky differentiation, but hopefully that made sense. It's that's one of the more tricky of the four, the difference between those two. Mean time between failures is how long between failures, right? So essentially, if you have a failure on Monday and you have a failure on Wednesday, again, the mean time between failures in that instance, with the example of one, would be like 2 days, right? So you want to keep your mean time between failures as long as you possibly can, because the longer time between failures means that you're basically not failing that frequently and that often, and the less failures, the better. All right, so pause and read all that, but basically you just need to understand that concept there as I described it. So again, RPO, RTO, MTTR, and MTBF, you do need to be able to have a look at a description and say, oh, that's this, or that's this, that's this, that's this. And you also need to be able to really, unfortunately, just simply read the letters there and be able to describe what that is. It might just say, what is RPO? And you might have to say, oh, that is this. So that's exam objective 3.3. We're on to what I believe is the last question now. So we're almost there. This question reads, a penetration tester is evaluating a company's internal network security. They configure their laptop to send specially crafted frames, tricking a switch into believing that their device belongs to a different VLAN than its actual assigned port. By doing this, the tester is able to bypass the segmentation intended by the network administrators and gain unauthorized access to resources located on a separate, supposedly isolated network segment. Which type of network attack is being described in this scenario? Is it A DOS/DDoS, B, VLAN hopping, C, MAC flooding, or D, ARP poisoning? Just ignore the fact that that's indented, that's irrelevant. Your answer coming in 3 seconds. Pause the video if you need to. 3, 2, 1. Your answer is VLAN hopping, and it's pretty much in the name, guys. That was VLAN hopping. That is when you're targeting the switch to try to convince it to basically make you jump from one VLAN to another VLAN. So by tricking the switch, you can get into another VLAN, getting around those security policies preventing you from otherwise doing that. Long story short, just know if you're going from one VLAN to another VLAN, by tricking that switch, you are doing VLAN hopping. It's in the name. That one's kind of intuitive, right? Sometimes the names sound too good to be true and you're like, oh, it can't be VLAN hopping. That sounds too simple. And you might try to pick another one. But no, in this case, it actually was as simple as it seemed. The other options there, DOS or DDoS, we should know now that that's denial of service or distributed denial of service. And that's basically when you are trying to disrupt a service, generally by just taking it offline in any way, shape, or form. Denial of service is like one or very few devices, usually sending data to a server to get it to go offline. Distributed denial of service is that on a massive scale. So you might have a botnet of hundreds or thousands or millions of different computers all sending data requests to a server in order to overload it and get it to shut down. Also, denial of service can just simply be, technically, if you smash a switch with a hammer, that's a denial of service as well. Impact and vulnerability, right? Of course, if a service is offline, it's not good. Just know that's what a DOS/DDoS is. All right. So with that being said, the other two options there were MAC flooding. Now, this is where you're trying to overwhelm a network switch with a very large number of fake MAC address port mapping. So basically, when the table is overflowing, the switch behaves like an Ethernet hub and just broadcasts to absolutely everything. All right. So by overflowing that table, by giving it so many MAC address requests, by so many MAC addresses, you're going to overflow that table. It's going to get confused and it's going to broadcast all of that data. And if you're broadcasting all of that data, what's going to happen? There's going to be the network's basically going to be down because there's just too much traffic going on. So you're forcing that broadcast mode there. Additionally, by forcing that broadcast mode, attackers can actually capture and analyze all network traffic, right? Because it's all being broadcasted. So you can just capture all data on the network. So if you want to find out something you probably shouldn't know, that's one way you could potentially do that. And the last option there was ARP poisoning, or ARP spoofing is another way to put it. So this is basically where you're sending a false address resolution protocol message over a local area network, which is tricking, again, it's focused on trying to trick. It tricks the network into associating the attacker's MAC address with an IP address of a legitimate network device. All right, so you might say, hey, my MAC address is actually associated with the IP address of the router. And you know, if that's the case, you're going to be able to capture the traffic going through the router in that instance. All right. So you send an unsolicited or forged ARP reply to the network, ARP reply, asserting that their MAC address corresponds to the IP address of another device. And if you can successfully trick that device, then you're going to essentially poison the table, which basically means there's falsified data in there that will benefit the attacker. In this case, rerouting data meant for someone else to the attacker's device, because the network thinks that the MAC address is associated with their IP address. So this allows a man-in-the-middle attack, because if you're getting data that you shouldn't, you can modify it and then send it on its way, or you can just capture it yourself as well. That comes from exam objective 4.2, which has summarized various types of attacks and their impact to the network. And I've highlighted the specific sections that we looked at there in that question as well. Now, guys, if you have found this video helpful and you think it has helped you prepare for your Network Plus, then please make sure you give the video a like, leave a comment, let me know, and share it with your grandma as well, because she might be interested too, or your cat could watch it. Anyone, really, just help me out. And I'll see you in the next one. Let me know when you pass and if I've helped you pass as well. Okay, bye guys.